Hi, algebra students. These are your notes for section 4.3 on parallel and perpendicular lines. So we're going to start by covering some vocabulary. So first, let's talk about parallel lines. Parallel lines are when two or more lines don't ever meet. Okay, so think, again, like railroad tracks are a good example of parallel lines. Okay, so two lines that just keep going on and on for an ever and ever, but are never going to meet or never going to intersect. Parallel lines, because they never intersect, they're always going to have the same slope. We're also going to talk about perpendicular lines today. Perpendicular lines are two or more lines that intersect to form four right angles. So think like a plus sign. And in parallel lines, there's those four right angles in all four corners. Perpendicular lines have slopes that are opposites and reciprocals. And we'll come back and talk about that in a little bit because sometimes that's confusing. So perpendicular lines have slopes that are opposite reciprocals. That's how you need to remember that. So let's start by taking a look at these examples where we're going to graph some lines on the coordinate plane. So this will give you some practice with graphing. So the first line is already in slope-intercept form. So I'm going to start by plotting a point at positive 3. And then using my slope up 1 over 3. I can also count my slope backwards and go down 1, back 3. And then I'm going to catch that and make a line. So remember, I'm going to use my line tool to do that. And I want to put a line right through those 3 points. Okay, so that's pretty close to where it needs to be. And then let's take a look at this next equation. So for this next one, I'm going to change this into slope-intercept form by subtracting 1 from both sides. So this one is going to say y equals negative 3x minus 1. So this time I'm plotting a point at negative 1. My slope is negative 3, so I go down 3 and over 1, or up 3 and back 1. Okay, so I'm going to connect those again, grab my line tool. Okay, and let's talk about these two lines. So it looks like, just looking at them, that they might be perpendicular. So I'm looking at this section right here. Make sure that you're not just using your naked eye because sometimes it can be a little deceiving. So I want to make sure that I actually look to see, are the slopes opposite reciprocals? So in the first equation, I have a slope that is 1/3. In the second equation, I have a slope that is negative 3. So those are definitely opposites. One is positive and one is negative. And then the reciprocal of 1/3 is positive 3. So I would definitely say that these two lines are perpendicular. So I can see that, but I also proved that by looking at the slopes of both of those lines. So they're going to have slopes that are opposite reciprocals and then different y-intercepts. Let's take a look at number 2. This time again, I'm going to take that first equation and I'm going to change it into slope-intercept form. So the first thing I'm going to do is add 4 to both sides. So 2y equals x plus 4. And then if I divide both sides by 2, y is equal to 1/2 x plus 2. And then the second equation, if you want to rearrange it, you can, is y equals negative 2x plus 5. I just changed to the order of those terms so that I could easily see. So let's go ahead on this one and make a prediction. So looking at the slope of these two lines, I can see that the slope of the first equation is negative 2, and the slope of the second equation is 1/2. So again, I would predict that these two lines are going to be perpendicular just by looking at the slopes, but let's go ahead and put them on our graph. So I'm going to graph the first one. I'm going to plot a point at 5. My slope is 2. Oh no, it's negative 2, so I'm good here. So down 2 over 1, down 2 over 1. I can keep going and following that line, and then I'm going to grab my line tool here. and graph that line. Okay, so let's go to our second equation. So this time I need a y-intercept of +2, and I'm in a slope of 1/2, so up 1 over 2, up 1 over 2. There we go. Grab my line tool again. Okay, just to make sure I had that. And again, this one actually came out really nice. You can see those right angles in each of those corners. All right, so let's take a look at this last one. And this time, again, the first one is already in slope-intercept form. Remember, this one has a y-intercept of 0. I'm just going to go ahead and start graphing this line. So it has a y-intercept of 0, and it has a slope of -2/3. So down 2 over 3, or up 2 and back 3. And then I'm going to go ahead and grab my line tool, graph this line. That one passes right through the origin. Okay, so let's take a look at our second equation. This one, I'm going to subtract 2 from both sides. So in slope-intercept form, it's going to say y equals 3/2 x minus 2. So when I plot this one, I start at -2. I go up 3 over 2, up 3 over 2. I'm going to grab my line tool and graph that line. Okay, so again, it appears as though these two lines are perpendicular. Let's take a look at the slopes of both of these lines. So in the first equation, my slope is -2/3, and in the second equation, my slope is 3/2. So again, in looking at the slopes of these two lines, I can see that they are opposites, and they are indeed reciprocals. So that proves again that these two lines are perpendicular. All right, so what do you notice about the intersection of each pair of lines? So it says find a pattern of pairs for each set of lines. So slopes, we noticed, were opposite reciprocals. So let's look at how we would utilize that to help us come up with the slope of a new line without actually having to draw it. So we have a given line that is has the equation y equals 4x plus 8. So in the given line, the slope is 4. So we want to find the slope of a line that is perpendicular to this line. So that means the slope needs to be the opposite reciprocal. So the slope of the new line is going to be -1/4. So it's the opposite of 4, and it's the reciprocal of 4. Okay, same thing with number 3 in the given line. Now look at this one. So this is an x equals equation. So remember, this is our vux. It is a vertical line. It has a slope that is undefined, and it's an x equals equation. So what do you think the slope of a perpendicular line to a vertical line would be? Of course, that would be a horizontal line. So we need a horizontal line, and that has a slope of 0. Okay, we're going to take this one step further, and now it says write the equation of a line that is perpendicular to y equals 8x minus 4y equals 12 and passes through the origin, okay? And the origin, it says the hint right here is 0, 0. So the first thing I'm going to do is change my equation from slope-intercept form, from standard form, this is in standard form, to slope-intercept form. So I'm going to subtract 8x from both sides. And then I'm going to divide by -4. Okay, just checking my signs here. So y equals 2x minus 3. So that means I want a line that is perpendicular to this line. So in the given line, the slope is 2. So that means in the new line, my slope is going to be negative 1/2. It has to be the opposite reciprocal, but that's not all. They want us to write the equation of that line. So that means I need to plug in the point. In order to find the y-intercept of this line, I need to plug in, remember the point is giving me an ordered pair x, y. So in the form, I'm just going to keep working over here. If I use my mx plus b, I want the slope of my line to be negative 1/2. I know that x and y are both 0, and I'm finding b, okay? So b is equal to 0. So that means the equation of my line is just y equals negative 1/2 x. Number 5 says write the equation for a line that is perpendicular to 2/3 x and passes through the point 2, 3. Okay, so this time I need to first find what is the, and I should have been showing this to you guys, when you do the symbol for perpendicular, it looks like a little upside down T. So the perpendicular slope for this line, the perpendicular slope would be negative 3/2. And then we want the point 2/3. So again, using our slope intercept form, y equals mx plus b, we would put, this is our x, this is our y, so 3 goes in place of y. We want our slope to be negative 3/2. We want our x to be 2. And we need to find our y-intercept. So this time, I can do a little cross-canceling here. So 3 is equal to negative 3 plus b. So if you add 3 to both sides, b is equal to 6. So once you find your y-intercept, you take your y-intercept and your perpendicular slope and you write the equation of the line. So y is equal to negative 3/2 x plus 6. So my line has to have a slope of negative 3/2 and it has to have a y-intercept of 6. All right, let's do something different here. So this says use the graph to determine which lines are parallel or perpendicular. And we haven't talked much about parallel lines, so let's go back and review. Remember we said parallel lines have to have exactly the same slope and perpendicular lines have slopes that are opposite reciprocals. So for example A, what I'm going to do is just identify the slopes of those 3 lines using rise over run. So the slope of line A, which is right here, using rise over run, or in this case I'm falling, it looks like it's down 2 over 1, down 2 over 1. So my slope is negative 2. The slope of line B, that's this line right here, so it looks like I'm going up, or actually up 1 over 1, up 1 over 1. So my slope is just 1. And the slope of line C, let's take a look at the slope of line C, is this line right here, the lighter line. And on this one, I'm going down 2 over 1, down 2 over 1. So the slope of that line is negative 2. So it looks like this one, line A and line C, have slopes that are exactly the same. So I would say line A is parallel, and you can use that symbol, to line C. Okay, let's do the same thing. Actually, I'm going to let you guys do example B on your own. So find the slope. Again, what is the slope of line A? What is the slope of line B? What is the slope of line C? Okay, and remember, don't just use your visual cues. You have to have work to support your answer. You have to have proof there. Okay, moving on, we're going to take a look at how we use 2 points to find the slope to compare. So you want to think, how do I find the slope when I have 2 points? So remember, this is our slope formula. So our y sub 2 minus y sub 1 over x sub 2 minus x sub 1. A subtraction sign there. So change in y over change in x. So we're going to find the slope of each of these lines. So I'm going to start with line A. So the slope of line A would be -1 minus -4. Remember that subtraction sign does not take the place of the negative. And then -1 minus -2. So doing my state change, that gives me 3/1, or just 3. The slope of line B, let's do that one. 2 minus -4 over 1 minus -1. So in my numerator, that would give me 6/2, or 3 again. And then the slope of line C, so I would do 2 minus 3, and then 4 minus 2 in my denominator. 2 minus 3 is -1. 4 minus 2 is 2, so it's -1/2. So for this set of lines, my answer would be line A is parallel to line B, because they both have the same slope. Both lines A and B have the same slope. I would like you to try the second set of points. And remember, you're looking to see if they are parallel, but they could also be perpendicular. So make sure you keep an eye out for that. All right, so let's go to our last example here. In this section, we are using equations to find the slope. And again, we're looking to see, are any lines parallel or perpendicular just by looking at the equations. So I'm going to take a look at this first set, and I can tell that line A is in standard form. So because lines B and C are already in slope-intercept form, the first thing that I'm going to do is rewrite line A so that it's also in slope-intercept form. So I'm just going to add 2x to both sides. I'm going to divide everything by 5. So y is equal to 2/5 x plus 1/5, okay? And I know that's weird, but really all I'm looking at here is I'm just looking for the slope of this line. So in this line, the slope is 2/5. In line B, the slope is 5/2. And in line C, the slope is 2/5. So in this one, I don't need to do any more work other than just to look at the slopes. And I can see that based on what I've calculated here, that line A is parallel. Line A and line C have the same slope. So line A is parallel to line C. Even though line B is the reciprocal of 2/5, it's not the opposite reciprocal. So therefore it is not perpendicular. So be careful about that. So you just have two lines that are parallel there, okay? I'm gonna let you do the second set of equations there. Look at those, decide whether lines are parallel or perpendicular. And then we'll come back and talk about those examples that you did on your own in class, okay? So I hope that you got everything, and don't forget to ask any questions that you need to regarding anything we discussed in 3-4. Have a great night.